crude oil. It's one of the most valuable natural resources on planet Earth, and it's the main ingredient in North America's most widely used roofing material, asphalt shingles. Unfortunately, asphalt shingle technology has not improved very much in nearly a century. But in 2007, GAF Elk Corporation, North America's largest roofing manufacturer, set out on a mission: create the industry's first advanced protection shingle. A shingle that would offer superior performance while reducing the use of precious natural resources. A daunting task indeed, in an industry not known for major technological advances. Asphalt roofing shingles are designed basically the way they were 100 years ago. A paper or fiberglass core is coated on both sides with a mixture of asphalt and organic fillers. Ceramic-coated colored granules are added for protection and appearance. Finally, a stripe of special adhesive was added in later designs to improve wind resistance. Today's most popular type of asphalt shingles, which are called laminated shingles, are made of 2 layers of roofing material layered together. Once the shingle has been installed and exposed to the sun, the adhesive activates and locks the shingle in place on the roof. All of these materials are derived from natural resources, with asphalt being the major component. It was time for new thinking. So many industries have utilized modern technology to improve their products, like cars, which became lighter with enhanced performance, and microfibers, which provide greater permeability and strength even though they're thinner. So, why not roofing? To develop the industry's first truly advanced protection shingle using less natural resources, GAF Elk's scientists started by evaluating the best design characteristics of GAF's and Elk's existing shingles. Dr. Lou Hahn talks about the process.
Combined, GAF and Elk shingles already protect tens of millions of homes throughout North America, so it would have made no sense to throw out everything we'd already learned. But to achieve our goal, we knew that we'd need to look beyond the roofing industry to incorporate the most advanced technologies and manufacturing techniques from throughout American industry.
Drawing on the collective knowledge of the 2 companies, GAF Elk scientists began to visualize what an advanced protection shingle might look like. The problem in a conventional asphalt shingle is that during the manufacturing process, the fiberglass core absorbs significant amounts of asphalt and filler, adding to the weight of the shingle, but not to its performance. That wastes natural resources and can even result in reduced performance. GAF Elk scientists set out to design a revolutionary new type of core that would minimize the amount of scarce raw materials wasted during the manufacturing process, while improving performance. This proprietary advance includes a change in the concentration and orientation of glass fibers in the core. The next major breakthrough was to redistribute the asphalt coating from the back of the shingle to the front, where it matters most for superior weathering performance. Finally, a specially formulated self-sealing adhesive was developed and incorporated into the design. The end result was a slightly lighter weight shingle. But would it perform? To answer that question, Lou Hahn turned to GAF Elk scientist Dr. Sudhir Railkar. Dr. Railkar is an expert in advanced computer simulation.
We developed a proprietary model using custom simulation software similar to the model I had developed for the Space Shuttle program for NASA. The model told us that the new shingle design would achieve performance characteristics which we had never measured before in anyone's shingles. Each shingle is divided into 10,000 sectors. So using the model, we can figure out how stresses develop over time on shingles and thereby predict performance in the long term.
Unlike conventional tear testing, the model predicts the long-term stresses on each sector using decades of real-world data. The same approach has been used to project the long-term stress on bridge design, particularly relevant because both bridges and shingles are expected to last for decades.
We summarized thousands of hours of research and development into the blueprint for the next phase of the project. Basically, we were able to design a shingle that reduces our dependence on precious natural resources so that we can improve our environmental impact without compromising quality. In fact, we were actually able to improve the ability of our shingles to withstand rooftop stresses and wind damage while reducing their overall weight.
Designing a new product in the lab is one thing. Being able to produce it consistently under real-world conditions is another. So when the design team approached manufacturing, they were skeptical.
The proposals they were making were quite frankly beyond the capability of many of our manufacturing facilities. However, I knew that if we could pull it off, we'd be taking a significant leap forward in shingle technology.
Fortunately, GAF Elk's manufacturing operations are recognized by many as the most advanced in the industry. If anyone could make the vision of an advanced protection shingle a reality, it would be them. Working closely with the product designers, revolutionary new manufacturing improvements were developed to produce the new shingle. Michalski and his team knew that the new shingle design would require a level of manufacturing sophistication that rivaled the very best available in any industry. They set out on a company-wide program to assess each plant's ability to manufacture the new design. Michalski knew that state-of-the-art process controls would be critical to success. So older systems were upgraded or replaced, and new cutting-edge process technologies were added. Advanced distributed process controls were added to the plants to monitor up to 2,000 critical process variables during production. And nuclear-powered measurement gauges, similar to the technology used for medical body scans, were incorporated to ensure dimensional consistency. The newest technologies allowed the plants to control tolerances to within thousandths of an inch. Michalski adds,
The level of computer sophistication we've added in our manufacturing facilities is so great that, quite frankly, the plants almost run themselves. Most of the associates are there to monitor the computers, verify visual appearance, and ensure compliance to codes of our shingles.
To ensure consistency of both raw materials and the finished product, over 25 new raw material specifications with 250 measured properties were developed, along with another 40 critical properties to be tested after manufacture. After thousands of hours of plant testing, scores of trial runs and modifications to the process, the manufacturing team produced their first advanced protection shingles. But how would the new design live up to the promises?
This was the moment of truth for us. We were confident that if manufacturing could produce the new design, it would exceed all standard tests that the industry uses to measure quality and compliance with code requirements. But our testing protocol is significantly tougher than industry standards. So when the first shingles were produced, made in a real plant under real-world conditions, we were ecstatic to find that they performed nearly identical to how our models predicted. It was everything we could have hoped for.
Fundamentally, GAF Elk had advanced the life of the roof by increasing the shingle's strength and its ability to withstand rooftop stresses. In fact, the new advanced protection design performed so well that every one of GAF Elk's shingles has passed the ASTM Class F 110 miles per hour and Class H 150 miles per hour wind resistance tests, the two toughest wind resistance tests for any shingles, and a significant step forward for the industry in protecting consumers' homes. While the development of the advanced protection shingle was a success, the mission hasn't ended. GAF Elk scientists are continuing to experiment with new and advanced materials for asphalt shingles, some of which were unheard of just a few years ago. GAF Elk's goal is to be at the forefront of shingle technology, not only to design the very best protective shingles for our customers' homes, but the very best looking ones as well, while using as little of the world's natural resources as possible. As the industry leader, our company owes this to future generations.